Hi everyone. So in this video we are going to learn about equilibrium of particle. Okay, equilibrium of particle. Now as per NCERT, what is written here, equilibrium of particle in mechanics refers to a situation when net external force on the particle is zero. Okay, now suppose this is one particle or an object. It is acted upon by multiple forces, F1, F2, okay, F3 acting in this direction, F4 acting in this direction. So it is acted upon by various forces. Now if the net force is zero, net force acting on this is zero, that is F net is equal to F1 plus F2 plus F3 plus F4, vector sum. Okay, this is all vector sum. So if the resultant force or the net force on the body, this body, if it is zero, then we will say that the body or the particle is in equilibrium. Okay. Acha. Now from second law we have seen that F net is equal to mass into A net, mass into net acceleration. Okay. Now if F net this is equal to 0, this implies net acceleration is 0. Net acceleration is 0. So net acceleration 0 implies the velocity of the particle is constant. Velocity of the particle is constant. That means if the particle is at rest, it will continue in the same state. And if the particle is moving with constant velocity, then its velocity is not going to change. Okay. This is the condition for equilibrium of particle. Okay. Now let us take few examples. Now suppose we have an object acted upon by two forces, only two forces. Okay. So that means suppose this object, it is acted upon by force F1 in this direction and F2 in the opposite direction. Okay. Now if this object is to be in equilibrium, for equilibrium, we have seen that the net force should be 0. Net force should be 0. So that means F1 plus F2, it should be equal to 0. Now this implies F1 is equal to minus F2. F1 equal to minus F2. That means the two force must be equal and opposite. Okay. These forces must be equal and opposite. Equal and opposite. Okay. What is the meaning of equal and opposite? Equal means equal in magnitude. Okay. And opposite means opposite in direction. Okay. Now this is the case when you have two forces. Okay. Now let's see what happens for three forces. For three forces. Okay. Now suppose this point, this is a particle and it is acted upon by three forces. Okay. Now one force, it is acting in this direction. This is F1. One force, it is acting in this direction. This is F2. Okay. And one force, it is acting in this direction. This is F3. Okay. Acha. Now for these two forces F1 and F2, the resultant, what will be the resultant? If we use parallelogram law of vector addition, this will be the resultant. Okay. This is F1 plus F2. That is the resultant of these two forces. Okay. Now if this particle is to be in equilibrium, that means F1 plus F2 plus F3, this should be equal to 0. Net force should be equal to 0. So that means F3 should be equal to minus F1 plus F2. So that means F3 should be opposite to the direction of resultant of F1 and F2. Okay. and magnitude of F3 should be equal to magnitude of the resultant of F1 and F2. Okay, that is the mathematical explanation. But how to represent this thing in vector form? Because if the particle is in equilibrium, how to represent this in vector form? So for equilibrium condition, if this is F1, so this is F1. Okay, this is F2, so this is F2. Okay, so I'm basically what I'm doing, I am shifting these vectors parallel to themselves. Okay, so during lateral transformation, the property of the vector remains invariant. That means vector does not lose its magnitude, vector does not lose its direction. Okay, now for this F3, I'm drawing it like this. This is F3. So that means if F1, F2, F3, these three vectors are along the three sides of a triangle taken in same order. So here F1 is F1, F2 and F3, they are in anti-clockwise direction. So in this case the resultant will be 0. Okay, now these things we have also seen in vectors, that is in Lamys theorem. Lamys theorem. Okay, so what does the Lamys theorem says? Now we have discussed the Lamys theorem in detail. Okay, here I will just give you a review of the Lamys theorem. Now suppose you have this force is F2, this is F1 and this is F3. Okay, now suppose this angle is alpha. Alpha is the angle between F2 and F3. Okay, this angle is beta. So beta is the angle between F3 and F1. Okay, and this angle is gamma. Gamma is the angle between F1 and F2. Okay, now the Lamys theorem says that at equilibrium, F1 plus F2 plus F3 is equal to 0. Okay, and then we have seen just now that how we can represent these three vectors as this is F1 and this is F2 and this is F3. So the three vectors are represented along the three sides of a triangle taken in same order, means same sense of rotation. Okay, so then their resultant is 0 and we say that the vectors are in equilibrium. Okay, this is the equilibrium condition. Now from Lamys theorem, now the Lamys theorem says that if at equilibrium F1 plus F2 plus F3 is equal to 0, then F1 by sine alpha is equal to F2 by sine beta is equal to F2 by sine beta and is equal to F3 by sine gamma. Okay, so if F1 plus F2 plus F3 is equal to 0, okay, then we have this condition. So this is Lamys theorem. So for equilibrium condition, we can use this theorem to solve questions. So in this question, we have a block of mass 30 kg, okay, 30 kg, and it is suspended by three strings. So this is string A, this is string B, and this is string C. Okay, and obviously the block is in equilibrium, and we are asked to find the tension in each string. So now let us take the tension in string A to be TA. Okay, tension in string B to be TB. Okay, and tension on string C to be TC. Okay, the strings are different, so obviously the tension will also be different. Okay, so similar, this TC at this point, it is acting in the downward direction, but for this block tension will act in the upward direction, and that will be same TC because string is same. Okay, acha. Now let us apply the equilibrium condition. Okay, now we are going to solve this question in two methods. Okay, first we will see that for equilibrium the net force should be equal to 0. Okay, net force should be equal to 0. Now see, if we take this direction as x-axis and this direction as y-axis, horizontal direction as x-axis and vertical direction as y-axis, then if the body is in equilibrium, then it implies the net force, summation of all forces along x-axis, this should be equal to 0. Correct? Acha. Now let us find all the forces which are acting along the horizontal direction. Okay, so we have one force TA. Okay, this force is acting along horizontal direction. It is acting along this horizontal direction, isn't it? Acha. Now TB, this angle is 37 degree. So that means if we take this as horizontal direction, so this angle will be 37 degree. 37 degree. Okay, so that means this component of TB will be TB cos 37 degree, and this vertical component, it will be equal to, I'm writing it over here, it will be TB sin 37 degree. Correct? Achha. Now if horizontal forces, sum of all forces along x-axis, this is equal to 0, so that implies this force TB cos 37, it is acting in this direction. Okay, and TA, it is acting in this direction, opposite direction. So that means these two forces must be equal in magnitude, and already they are acting in opposite direction. So TA should be equal to TB cos 37 degree. Cos 37 degree. Okay, now cos 37 is 4 by 5. So I can write this as TB times 4 by 5. TB times 4 by 5. Okay, so TA is equal to TB times 4 by 5. Now similarly, it is for equilibrium, net force acting along y-axis should also be equal to 0. Okay, now at this point, downward force is TC and the upward force is this quantity TB sin 37 degree. So that means if again net force along y-axis is 0, that means total upward force equal to total downward force. So total upward force is TB sin 37 degree, and that is equal to TC. Okay, sin 37 is 3 by 5. So I can write TB times 3 by 5, it is equal to TC. Okay, acha. Now if you see this block, now this block, it is acted upon by a downward force of 300 Newton and tension TC acting in the upward direction. Correct? So that means tension should be equal to 300 Newton because this block is also in equilibrium. So that gives TC is equal to 300 Newton. So TC is known. So if TC is known, from this equation I can get the value of TB. Okay, so from this we have TB is equal to 500 Newton. TB is equal to 500 Newton. Now from this equation, TB is known. TA, it is equal to TB times 4 by 5. TB is 500 Newton. So if you substitute TB is equal to 4 by 5, then what you get? You get TA. TA is equal to 400 Newton. Okay, so TA, this is TB, and this is TC. Okay, so this is one way of approaching this question. Okay, now let us solve this question using Lamys theorem. Now for Lamys theorem, see, we need to know few angles. Okay, now see here this angle is 90 degree. This angle is 90 degree. Okay, acha. Now here this angle is 37 degree. This angle is 90 degree. So that means this entire angle, what will be the value of this angle? It should be equal to how much? It should be 37 degree plus 90 degree. 37 degree plus 90 degree. Okay, now similarly this angle, it should be equal to 180 degree minus 37 degree. 180 degree minus 37 degree. Okay, now tension, they are marked as, say, this is in this direction, you have tension TA. In this direction you have tension TB. In this direction you have tension TC. Okay, now if you have to use Lamys theorem, Lamys theorem. Now Lamys theorem, from Lamys theorem what do we have? TA, force divided by sine of opposite angle. So if you are taking tension, this tension, angle is this angle, sine of 90 degree plus 37 degree is equal to TB. TB is this direction, so angle is opposite angle we have to take, so this angle is 90 degree, so sine 90 degree is equal to TC. TC is this direction, so that means we have to take this angle, so that is sine 180 degree minus 37 degree. Okay, now here from, see, this is this force is here, which is actually, this is not 300 Newton, this is 30 kg, so this is 300 Newton. Okay, so for this block, downward force is TC, 300 Newton, upward force is TC, so this gives TC is equal to 300 Newton. Okay, so this quantity is known, TC is known. Okay, we know the value of sine 180 minus 37 degree. Okay, so from this we can get the value of TA. So TA, it will be TC times sine 90 plus 37 is cos 37, so cos 37 degree, TA equal to TC into cos 37 degree, sine 180 minus 37, so that is sine 37. Okay, cos 37 by sine 37, so that is cot 37, this is 300 degree. Okay, so this is equal to cos, so cot 37 is 4 by 3, so 4 by 3 into 300, so that is 400 Newton. TA is 400 Newton. Okay, similarly from this we can get TB is equal to 500 Newton. Okay, so this is how we can use Lamys theorem to solve equilibrium question.